It's here. Today we test the SKR EZ. Hello everyone, Chris here, and yes, BIGTREETECH has yet another mainboard out on the market, the SKR. Now there are two flavors of the SKR. There's the standard one and then the EZ. Now in between the SKR2 and SKR boards, there are some changes, but the biggest one being on the EZ model. They've actually changed the form factor of the stepper drivers they used. They've stood them on their edge. Now there could be a lot of benefits to doing this, but there could be some downsides. So I have a lot of thoughts about this one, but that's what we're going to do today. We're going to get it out of the box, see what's going on with the new board, get it installed, and any bumps that I run into, I'm going to share all those with you. So let's don't waste any time. Let's get into the box and see what we got. So here we go. What is in the box? Here's our board. No duck. Let's see what's underneath here. We get a USB cable. And we get a bunch of JST plugs and pins so you can make all your wires. That's new for BIGTREETECH. So that's pretty nice. So this way, if your printer doesn't have them, you have them right here. You can just make them up. Here's a look at the board. You do get jumper caps. You will need these to set a few things around on the board. We'll go over that. And there's an up-close look at it just in general. Now, before we go over the features of the new SKR boards, let's compare it to the 2. Remember, there are two new SKR boards, the 3 and then the 3EZ. This is the EZ. Because of the way the new drivers are laid out on the EZ model, it is quite a bit larger than the other SKR boards. Up until now, the EZ board, they all had the same layout. They were the same size. The 1.3, 1.4, the 2, and now the new 3 is the same size. But the EZ version of the 3 is going to be quite a bit bigger. So keep that in mind. The SKR2 and SKR are somewhat similar. There's a few more features on the 3, but for most 3D printing users, I would say it's not going to be that much different. I think honestly, one of the best things they did on the 3 is now they've upgraded to blade fuses rather than the micro fuses. Those are really frustrating to find. So right out of the gate, I think that's one of the best things that they've done. So the regular SKR might not be that big of an upgrade for you. But the EZ is very interesting. So let's take a look at some of the features here. Let's just start with the processor. The processor on the SKR this is an STM32H743 VIT6. This is a 480 megahertz processor. And then the drivers. You can use the regular old silent boards that we're used to on these, or you can use their new driver, the cartridge type, and we'll take a look at those in a minute. You have jumpers down in here, just like the SKR to set your sensorless homing if you'd like on each one of the drivers, so you don't have to cut any pins, no matter which driver you're using. And then you have these jumpers right here. What this allows you to do is set the motor voltage. In this position, the motors will be driven by the input voltage of the board. But if you put them on this other set of pins, you have an input right here that you can plug in up to 48 volts to drive your motors independently. And that's something I've never seen on a board yet. Now, this input voltage does have a micro fuse. Probably not a lot of folks are going to be using this right out of the box, but just note that. So you have a lot more flexibility of what motors you want to drive and what drivers you want to use. This board will operate at 12 or 24 volts, and again, up to 48 volts for the motors. This board does have a dedicated EEPROM chip, and they have upped the quality of the voltage regulator. The regulator has always been a weak spot on a lot of these boards. That shouldn't be an issue going forward. They also do have this safety chip down here to keep you from damaging your drivers if they didn't get installed correctly. But with the new style of driver, that shouldn't actually be a problem anymore. You get 3 controllable fans. You can control these with G-code. And then you get 3 always on fans up here. 2 end stop plugs for your Z, pretty standard. Of course, those are both controlled by one single driver, so they're not independent. But you could always use your 5th driver. That's what we're going to do today. Remember, on some of these boards, these are flipped from time to time. We're usually used to using this one as power in, but this is actually the heat bed, and this is the power end. So we'll go over that when we install it. And then one of the biggest upgrades to this board is you now get a CAN bus. This is getting more and more common to see on boards, and firmware is starting to support it. What is a CAN bus? We could talk about that all day, but it's a controller area network. It's a very robust way to control MCUs on a network. You're starting to see more boards come out. Duet makes a few now that can control your extruder or a motor, and you just have to plug it in on the CAN, and it knows what to do. So as we get more involved with these machines, that's going to become increasingly handy. So it's good to see they support it. This is both on the 3 and the 3EZ. You have the switch over here to control the CAN mode. You get all the usual stuff: probe pins, RGB, power detect, filament runout, end stops, your EXP1 and 2 for your LCD screen, 2 thermistors, TFT pins, pretty much standard fare. You do have your jumper over here that you can power it up with USB or VCC in. If you need to power it up USB, you have your Wi-Fi module that you can plug in. That's sold separately. You can use a 7, a 12, or a 32 ESP module for this. That's if you want to run RepRap. This board does support Marlin, Clipper, and RepRap. So you can run pretty much whatever you want. And then one other of the cool features that I found on this one is you have these 2 plugs right here. They sell a module that you can plug in that will allow you to adjust your fan voltage no matter what your input voltage is. So if you have 12 or 24 volt, if you plug in this extra module and set some of these jumpers, you can run 5, 12, or 24 volt fans over here. It will allow you to control the voltage. So pretty neat to see. And here's a look at one of the new driver modules. These are pretty cool. It's just a little card that has the driver chip on it, and then it has a heatsink wrapped around it. It's screwed down there. There is some thermal paste in there. But standing up on their edge, it should be a lot easier to keep these cool. And they're easier to deal with. You don't have to deal with all the pins like you do on those silent boards. It's much easier to get the orientation correct on these. You don't have to worry about bending any pins. They have a little cutout here on one side. It's matched up to these sockets, and they just slide in. Just like that. Now remember, you do have that choice to be able to power these with an alternative power supply. So make sure that jumper is correct. By default, it should be correct to use DC in. But flip it to those other 2 if you want to use this input. I'm not going to be using centralist homing today, so I'm going to leave the cap off of these. And there's what it looks like with all 5 drivers installed. I like what I see so far. We'll see how it goes as far as testing. Now we can go ahead and move to the install, but I will mention I've seen the SKR3 anywhere from $55 to $65, and then you can get the board and all of the drivers, all 5 drivers, 2209s, for around $80. I'll leave some links to what I found on the internet. So the trusty log 3D printer will be getting this upgrade today. It does currently run an SKR2. Now, I almost wish I would have the regular SKR3 for this because I worked really hard designing the case for the SKR2, and this one's going to be quite a bit bigger. I want to try out the EZ for sure, don't get me wrong, because of these drivers, but now I have to rework yet another case. But no big deal. So like we normally do, let's just work our way around the board, get this thing installed, and then we can do some tests. Remember, like I said before, heat bed is here, DC in. Let's just go ahead and plug in the heat bed. Now, the bed, I say this every time, but it really doesn't matter unless you have an LED. Polarity isn't going to matter on a bed like this. But this one does have an LED. So negative on the outside, positive on the inside. This board should be able to support 10 amp of draw for the bed, around 6 amps for your hotting cartridge. We'll do the power in last, and then our heater, E0. It does have spots for 2. No need to worry about polarity on this one either. Remember, things like this, use ferrules on the end of your wires if you can. Link to the ferrules I use below. While we're here working on the bed, let's go ahead and plug in the bed thermistor. It's right over here. Now remember, you do have 3 controllable fans here, 0, 1, and 2. 0 is usually always the part fan, and then I use 1 as the hot end fan. And if you want to use a controller fan, that'd be good for fan 2. If you're confused about what pin is what, they do have really nice badging on the back. So you don't even need to go to the schematic, really. But you can see for the fans, we have fan 0, 1, and 2. So I'm going to plug my part fan in here. That's fan 0. And my hot end fan in fan 1. This will have to be configured in the firmware. I'm going to plug my filament runout sensor over here in E0 detect. My pin to probe in Z stop. I don't use probe pins for the pin to probe. I like to use Z stop. I'll show you that in the configuration. And then your hot end thermistor for your first heater goes right down here in TH0. Then we can plug in our motors. I do still have end stops on this printer, so we'll deal with those. But your X motor right here, X end stop right here. If you just have a 2-wire end stop like I do, you just want to use 2 of the pins. You don't need the voltage pin. My configuration, I use the outer legs of the micro switch. That's how it works. So it's signal and ground. Then right down from that, we plug in our Y motor. And our Y end stop over here, I use the same type of micro switch. And then I plug one Z motor in to the 3rd driver. Doesn't matter which plug. And then the other Z motor, I plug it into the 5th driver because I like to use the Z lead screws independently. It lets you do things like leveling your gantry, a few features that can be really handy having 2 drivers for Z. And last but not least, our extruder motor. If you have an LCD screen you want to use, you plug them in here. It's the standard rep style screen, the discount controller. There's a lot of different controllers out there. A lot of the touch screens will use these plugs too if you want to use Marlin mode. EXP1, EXP2. And now all we need to do is plug in our power. And remember, the input power is going to be that 2nd set of terminals. Positive on this side, negative on the other. We should be good. We can power up. I am powering this one with 12 volts. Now all we need is some firmware to make this thing work. By default, if you just power the board up, it does look like it has a bug fix version of Marlin on it already. Now, I have no idea how it's configured, so I don't know how to tell you. It does have some driver errors, so it's probably not set up correctly for our configuration. I wouldn't even attempt to use it, but just note that it does come with Marlin on it. So just a quick first look at the board after I've had it installed. I think they're going in the right direction here. A lot of the components have been changed up. They do have the CAN bus on it now, and those new drivers, they're pretty cool. I don't necessarily like the extra footprint it required, but it is what it is. They do still have the regular SKR3 with a lot of the upgrades, but it's the same footprint as all the other SKR boards. So again, they're going in the right direction here. And those new driver chips, they're a lot easier to handle, and it should be a lot easier to cool them. I just hope it becomes a trend. More people start making them. And the fact that you can use both still, that's a big win. But let's continue on with our firmware configuration. And we are going to load Marlin firmware on this machine today. And this video just got more exciting because now I just realized that 2.1 version of Marlin is out. We've been working with 2.093 and 2.092, but now we have 2.1, so I definitely want to check that out. So let's put that on there. We'll just download the zip. I just did an extract all on Marlin 2.1, and I made a copy of it for log SKR3. And you will need VS Code. I'll leave a link in the description on how you can configure that. So let's start working with it. We're going to model it towards log and get it set up, compiled, and put it on the printer. We're here in Visual Studio Code. I highly recommend you install the Marlin plugin over here, the extension. That's going to help you compile it. It's pretty handy. But we'll just open our Marlin folder. Remember, in VS Code, you need to open the folder that contains the Marlin folder. Here's the Marlin folder, so you need to go one up. So this one, we'll hit add. And we trust it. You'll know you've done it right because you'll have a PEIO folder here populate. We'll expand Marlin. And we need to work on configuration.h and advanced.h. And I'm going to do this pretty quickly just for the log machine here. I do have a lot of walkthroughs on configuring Marlin, so we'll hit the highlights today, just enough to get it up and running. I like to update my info on the build, just so I know what I did. We're good there. Then we need to update the motherboard. SKR is supported in Marlin 2.1. If you need that board name, just open up source and then core, and there's going to be a boards.h. It's listed by processor, so we can scroll down to the STM32 section. Ours is the Cortex M7, and we have the EZ model. So there's your board name right there. We can just copy that back to configuration.h. We'll paste it right here. Moving on, serial ports, depending on what you want to do. Or if you have a touchscreen, I usually just like to set this first one to -1. 250,000 baud rate is just fine. I don't have a touchscreen or anything like that, so I don't need to mess with the other serial ports. Custom machine name. We like to know that it is log. That'll display on the screen. Drivers. We have 2209s in UART mode, so all you need to do is put in TMC 2209, and we have those for all of our drivers. And we also have a Z2 driver. By default, it's going to use that E1 port like I showed during the install. I'll show you more on that in the configuration advanced file, but it also has a 2209. So we're good there. Then we come down to thermistor settings. I have an E3D thermistor on my hot end because it is a V6, so that's a number 5. And then the bed is a number 1, just a regular 100K. You can adjust your max temp here if you wish. The defaults are usually okay for me. PID is something you need to tune, but if you have an old configuration, it might be pretty close. So you can just put those values in. I do have one, so I'm just going to paste mine in here. Same way for the bed. I do like to use PID on the bed. So we'll uncomment this line, and then you can calibrate your values later. I'll leave a link to a video on that. Next thing we need to do is set up our in stops. We do have switches. We are using X, Y, and Z min plugs. And everything for my configuration to make it work, everything should just stay false. Nowadays, that's probably the most common setup. So I'm just going to leave them all false. We need to set up our default values for all of our motors. My X and Y are both 100. You can use the Prusa calculator to figure this out if you need to. And then my extruder, I'm usually setting around 140 in the E steps. Again, that can be calibrated. All of the default speeds here are fine for me right now. I usually set those with the slicer anyway. So the default limits should be all right. I do like to use classic jerk still, so I'll uncomment this. Again, something I set in the slicer, but we can set the defaults. I like them a little lower. I usually go with 8 and 8 on X and Y. If you don't uncomment that, you will be using junction deviation. I still just prefer the classic jerk. I really don't see a lot of difference in between the two. Then the probe, like I showed you how we set it up, I use the Z minimum in-stop pin, so that's the default, so that's uncommented. If you don't, if you want to use the probe pins, uncomment this one, comment the other one out, and then set up your probe pin. We are using a fixed mounted probe. We'll uncomment that line. If you're using the BL Touch, leave that one commented and uncomment BL Touch. Probe offsets, you can just calculate this with a ruler. My probe is to the right of the nozzle, 23. And in back of the nozzle, 6 millimeters. My Z offset is currently set to negative 1.1. That has to be calibrated. I have videos for that as well. On the bed that I have, I do not need a probing margin. I also don't have to use Z-safe homing, but I'll show you that when we get into the compile. That's a sanity check that we have to remove if we want to do that. Then we need to set our motor direction to make sure they're turning correctly. For my setup, I currently set X, Y, and Z all to false. And then my extruder motor, I set that to true. It's basically just how you have your wires set up for your motors. Flipping the cable over does the same thing. For the printable area, it's a Prusa style bed, so 250 in the X, 210 in the Y. And with my frame, just to be safe, I usually do max 200 on Z. Minimum position for Y is a little bit ahead of the bed, so I usually set that to -2. We do have filament run out, so we'll uncomment this line. I like to leave mine enabled by default, so you don't have to manually enable it. I only have one sensor, and its normal state is low. The default runout sensor, that E0 stop pin that we set when we installed the board, that's the default pin in your pins file, so it should work correctly. Bed leveling, I still go with auto bed leveling by linear, and I use 7 points for a total of 49 points, 7 by 7. You can see Z-safe homing here. It is disabled by default. I don't use it. Z-safe homing allows you to home in the center of the bed so you don't collide while you're homing Z. We can home at the corner of the bed. I'll show you how to turn that off. Additional features, I do like to enable EEPROM. Remember, this does have a dedicated EEPROM chip on the SKR3. This allows you to save settings with commands rather than having to recompile. There's a lot of different things you can save in EEPROM now. I like to update my filament temperatures. I usually do 215 and 60 for PLA. ABS is 255, 100. The nozzle park feature, you do need this, so uncomment this line. You have to have this to use filament runout. And I like to swap around the positions where the nozzle parks. I like it to park in the front right. So X max -10, Y min +10. And 20 is fine at Z. That's 20 from your current Z position, by the way. Then we get down to the LCD settings. As I mentioned before, we have a rep wrap display. We do use SD card support. And we'll turn on the speaker. And usually the first one on the list here is the screen that I use. The old 2004 rep wrap discount smart controller. And that should be it for configuration.h. Now we move to advanced configuration. There's not a lot in here we need to change, but still a few things. I want to update some information about our fans. Here you can use your controller fan. I just want to be able to use my controlled fan, E1, as my hot end fan. So you have to set a pin, and you can get that pin from the back of the board or from the BIGTREETECH website for the pinout. Here's their GitHub page. They do have some configured firmware, Clipper, RepRap, and Marlin out here if you'd like to grab their copy and use that as a baseline. That might make things a little bit easier. But then they also have the schematics and the pinouts for it. I'm using fan 1 right here for the hot end fan. That is PB6. So back to VS Code. Right here, E0, that's the fan pin we want to use. We're just going to put that in, PB6. And it should come on when the printer reaches 50C, when the hot end does. You can see here on Z drivers, if that Z2 driver is enabled, like we did in the configuration file, we set it to TMC 2209, there are some default settings. By default, it is going to use that E1 slot. But here, you can set up for multiple end stops, or you can invert the direction of one of the motors. So just know that those settings are there. The defaults are okay for what we're doing. But we do want to use stepper auto align. So we're going to take the comment off of that. That helps line up the X gantry. And we use our probe to do this. Instead of just going all the way to the top of the gantry and bottoming out, the probe will measure it. So we'll take the comment off of this line. We just have 2 motors, so we only need 2 sets of these values. We don't have to go to 3 locations, we just have to go to 2. So we can take one out, and then we have X and Y settings of each probe point. I usually like to go in 30 on X, and we'll go to the middle of the bed, so around 105. And then 220 on the right side of X. This is to help you to get that X gantry level. And then again, in the center of the bed's just fine, 105. That should be all we need for that. Power loss recovery, I'm not going to set that up for this build. I do like baby stepping, so we'll take the comment off that. There's a lot of different features here. You can enable it always. Usually it's just available when the printer's moving. I only find it useful on Z. I like to use double click for the button, the encoder to bring up baby stepping. And then down here, define baby stepping, Z probe offset. I like the baby stepping to set the offset rather than just moving Z up and down. Right under that is pressure advanced, linear advanced as we like to call it. I'm going to take the comment off that. But I do define the default value as 0 because I set that with an M900 command in my slicer. Arc support is enabled by default. That's for your G2 and G3 commands if you use those. And advanced pause feature. You do need this feature to use your filament runout sensor. Now, depending on your extruder, here's all your controls for advanced pause. How much filament it backs out, it pushes in after that M600 command. All that stuff is controlled right here, so you're going to want to play around with that. The only one that I do like to turn on down here is the load and unload G-code commands. So we'll uncomment both of those lines. And then in the drivers, I just like to adjust the current setting. You can do that after the fact if you wish, but you might as well go ahead and set the default value here now. We want to go to the TMC Smart section, has Trinamic, and you can see they're all set to 816 times. For a board like this with these drivers, that should be a great place to start. Again, you can use the M906 command to adjust that after the fact. I'm going to leave all my drivers in Stealth Chop for now. That's the quiet setting. Chopper timing, 12 volt. That is uncommented because I am using a 12 volt supply. And I do like to enable monitor driver status just in case I were to need it. That gives you a set of commands you can use to troubleshoot. And we're not using sensorless homing, so we don't need to turn on stall guard. I will turn on TMC debug, just in case. Just scrolling through the rest of this, I think that's everything we need to use our printer. So let's go ahead and compile. We'll save these files just for good measure. And we'll go over to the Marlin extension. This is auto build. You can go up here to the hammer. You can see we made a mistake with our board. There's 2 B's on it. So we'll correct that really quick. It sensed what board we had. It started to compile this time. It's going to download all the things it needs for the features for our board. And it's going to come up with an error after the downloads. This has to do with Z-Safe homing. And we actually hit another error before we even hit the one that I thought we were going to. It's talking about jerk values when using linear advance on your extruder. It strongly recommends default jerk to be greater equal to 10 when using linear advance. That's interesting. I've never seen that before. So we can adjust the jerk value and compile again. I'll have to look into that more. So I'll just set it to 10 for now. We can give it another try. It doesn't like one of our auto align points. So configuration _adv.h. That's because I was supposed to set it to 30, not 13. We can go again. And there's finally the sanity check error that I thought we were going to hit about centerless homing. I usually just adjust this in the sanity check. So back to Explorer. It's now in a warnings file where you can comment this out. And then we'll go to warnings.cpp. We can search for Z-safe homing. And we can just comment this error line out. Put 2 slashes in front of it. If you're not sure, go ahead and enable Z-safe homing. Don't comment this out. You don't want to collide the probe to the bed or have something bad happen. It's there to help you out. And it only took us a couple of attempts, but we have compiled successfully. You do have to load these firmware files with an SD card. I have a SD card loaded on the computer. It has been formatted FAT32. You can get to your firmware.bin right here in the Marlin tool, and it's going to be right here. So we can just copy that over to our SD card. We have our firmware. All we have to do is load the SD card on the board, and then power up. I did switch out the sheet. I like to use a sheet that might be a little damaged, one that I don't care so much about every time I do one of these new boards, just in case there might be some collision. It's a good sign when it comes up, you're on the right version. It did say 2.1. The thermistors are reading correctly. Let's go ahead and heat up. Let's just kick the nozzle on. Let's take it to 90 so that we can test to make sure the fan is going to spin correctly. The fan came on. That's good. We know we got that set up correctly. We can go back in there, go to temperature. Fan 1, these aren't labeled all that well. Fan 1 actually means the part fan. You can take that, let's just spin it up. And it did come on, so the part fan's working. So I'm okay with all of that. Let's go ahead and auto home. I'm pretty confident everything's moving in the right direction. If you're not, move them one at a time, but let's just go for it. We're going up, that's good. We went to the left, we went to the back. Z's coming down very slowly. Hopefully our probe is in good shape and it's going to work. And it did. It probed successfully. We can do our Z align. That's in motion as well. Auto Z align. It's going to home and then go to our probe points. Make sure the X is lined up correctly. So we're good there. All we really have left to do is an auto bed level. We can turn the bed up to about 60. And you can run the bed leveling sequence. When that's done, I know it completed successfully. We should be ready to go ahead and test a print. You can test whatever you like, make sure the filament runout sensor is going to work, all that good stuff. But I'm pretty confident my configuration was accurate enough that we should be okay. Now I just want to know how it prints. We do have baby stepping enabled, so when it starts its first print, you might have to adjust that Z height. We do have an offset set, but that's a whole other topic. But baby stepping with that Z probe offset option, you can dial it right in and save it. Your first layer will be perfect. So let's give it a try. And here's a look at our Benchy. This is actually probably one of the better ones that Log has created recently. Now, it really doesn't have anything to do with the board as far as quality goes, but it just shows that everything is clicking like it should be on our new board install. SKR3 is producing some pretty nice results. So there it is, our first look at the SKR3 EZ board. Now, I do like the board. I think they're going in the right direction. It has a lot of nice features, and they just keep getting better over time. But I also like the fact that they released an SKR3 and the EZ board, because you get to keep the same footprint that they've had for a long time now through all of their iterations. So that was nice to see. Now, I do like the new style of driver. I think that's pretty cool having the cartridge. They're really easy to deal with. But the best thing that they've done is they've kept you enabled to use both. You can use your silent step stick and the new type. That was the first thing I thought about when I saw that they were coming out with this. I didn't want it to be proprietary to BigTreeTech. So well done on that. And I think it's probably worth the extra footprint of the EZ board. Hopefully this becomes pretty popular with a lot of different drivers. Maybe even other people will make this type of driver going forward. I will keep testing it out. I will keep you updated on how my progress goes. But that will be it for today, and I'll see you really soon on the next one.